Hi guys, and welcome back to Introduction to Mechanical and Automotive Engineering. I'm your lecturer, Dr. Elizabeth Kyriakou, and we're still in week 3 of semester and looking at structural analysis. So in the first video we identified what a member was in a truss and also the joints. And we wanted to determine what the force is in each member of the truss and to determine whether that member was going to be in tension or compression. So in the next video we looked at method of joints and how to actually analyse the force in these members. So now we're going to take a look at another methodology, again to find the force in the member and state whether that member is in tension or compression, but there's another way to solve these problems. So let's take a look at method of sections. So if I take a look at this problem over here, and now I have a much more complicated truss than I did when I was looking at method of joints. So the question actually asks me to find the force in members JK, KD and CD. So to find the force in each of these members, if I was going to use method of joints, I'd have to go through each joint until I got to the middle of the truss, and that's going to be quite a lot of work. So there's a simpler way to do this. We can actually take a section through the truss and then have two problems, and we can use either side to actually analyse the force in these members. But the first thing that we need to do in all these problems is make sure that our system is in equilibrium, and we need to find our reaction forces. So let's have a look at this. A, we have a pin joint, so we're going to have AY and AX, and at G we have a roller, so we're just going to have GY. So what's the first thing that we're going to do? We need to find GY and our reaction forces at A. So find reaction forces. And I have three unknowns, AX, AY and GY. I have three equations for equilibrium. Some of the forces in the X direction equals 0. Some of the forces in the Y direction equals 0, and some of the moments around a point has to equal 0. So to find our force at GY, we need to take some of the moments around A. And I'll just draw a quick free body diagram. And here I have my truss. And here is G and A, and then I have some forces coming down here. And this is 20 kilonewtons, 30 kilonewtons, and 40 kilonewtons. And we have some distances, so let's just draw in the reaction forces first. So here we have AX and AY, and here we have GY. Let's put some distances in. We should identify our X and Y, which way is positive, and the height of my truss is 3 meters, and these dimensions are 2 meters each. Okay, let's calculate our reaction forces. So if I'm going to take some of the moments around A, which direction are these forces going to go into? So it's going to go this way, so these ones are all negative, and G is going to be in the positive direction. So some of the forces, some of the moments, around A has to equal 0. And what do we have? We have 20 kilonewtons. That's negative. And my perpendicular distance is 2 minus 30 kilonewtons, and my perpendicular distance is 4 minus 40 kilonewtons, and we have 6 meters. And then finally we have gy, so plus gy, and my perpendicular distance is going to be 12 meters. So I can solve for gy. So gy equals 33.33 kilonewtons. Guys, are you feeling comfortable about finding some of the moments around a point? If not, you need to do some more practice. So now I can find the reactions at AX and AY. So sum of the forces in the x direction has to equal 0. What's in the x direction? We only have AX. So AX is going to equal 0. And then we have sum of the forces in the y direction has to equal 0. And we have AY, which we calculated, or we are going to calculate. And we have minus 20, minus 30, minus 40, and gy is plus 33.33 kilonewtons. So we can solve for AY. And AY is going to equal 56.7 kilonewtons. Okay, so I've just done step 1 and found what my reaction forces are in this truss. So now I know that my truss is in equilibrium. Okay, let's clean this up and actually find the force in 3 members using method of sections. Okay, so we want to find the force in members. So step 2 is finding the force in members Kj, Kd, and Cd. And we need to state whether it's in tension or compression. Alright, so what we're going to do is we're going to take a section, okay? By cutting this truss, we are taking a section to expose these members. So if I just draw up that section, you can take a closer look. So over here, if I have, let's just make it a little bit wider. So here we have K, C, J, and D. And over here we have I and E. And on the other side we have L and B. Okay. So this is what my truss looks like right now. And then it continues over this way. And then on this side we have this going on. So what happens where I take this section? When I take this section, I'm going to have some exposed forces. So on this side, I'm going to assume again that all my members are in tension. So let's assume all members are in tension. which means they're going away from the joint. So here is my joint K, and I'm going away from the joint. I also have this member here. Again, I'm assuming that it's in tension, and CD's here. This is going to be KD, and this is KJ. So on the other side of the truss, I have to have exactly the same thing, and it needs to be equal and opposite. So these also have to be in tension. If they're not in tension, then my system's actually going to move. So we need to stay in equilibrium. So this side we have JK, KD, and CD. So it doesn't matter which side of the truss I solve, it's going to come out exactly the same. So in this problem, I'm actually going to solve it on this side of the truss. Okay? So what do we have? If we take a closer look here, we have two, let me just draw this completely into a free body diagram. So here we have D, E, F, and F and G. And here we have H. This goes that way. And so we know at G we have our reaction force that we calculated earlier, which is 33.3 kilonewtons. And we know that at D we have 40 kilonewtons, and that's in our question. So we're only looking at this side of the truss. So what else do we need on our free body diagram? We need to have some dimensions. So here I'm going to have 2 meters, 2 meters, and 2 meters. And the height of my truss is 3 meters. So we should write out our equations for equilibrium, because I think that's going to make us able to solve this problem a little easier. So some of the forces in the x direction equals 0, some of the forces in the y direction has to equal 0, and some of the moments around a point has to equal 0. So we need this system to stay in equilibrium, and it's very similar to when we were doing like reaction forces. So if we have two unknowns and one unknown, we should actually take moments around where we have two unknown forces. So I'm going to take the sum of the moments around D to eliminate these two forces. So we can say that to find Kj, we're going to take sum of the moments around D to equal 0. So what's going around D? What moments do we have? We have Jk, and that's going in the positive direction. So Kj, and my perpendicular distance is 3 meters. This force is going to go to 0 because it's acting through the point, and this is going to go in the positive direction also. So plus 33.33, and my perpendicular distance is 6 meters. So I can solve for Jk. So Kj is going to equal minus 66.7 kilonewtons. Okay, so what did we say? We assumed that the member was in tension, but we've got a negative number, which means the member is in compression. So we could rewrite it and say that Kj equals 66.7 kilonewtons in compression. Right, so how are we going to solve CD and KD? We can actually say that some of the forces in the x direction and some of the forces in the y direction, and we should be able to find these two forces. So KD needs to be broken up into its x and y components. So let's just do that. And we have an angle here of theta, and just theta equals tan to the -1, 3 on 2, which you can just calculate from geometry. So theta is going to be 56.3 degrees. So let's solve all the forces in the y direction first. So some of the forces in the y direction, just about to write the x direction, some of the forces in the y direction has to equal 0. And what do we have in the y? We have 33.33, that's positive, minus 40 kilonewtons, and we have the y component of KD, so KD sine 56.3 degrees, and that's going positive, so plus KD sine 56.3 degrees. So I can solve for KD. KD is going to equal, is that all we have? So KD is going to equal 7.9 kilonewtons, and since it's positive, it's going to be in tension. Okay, you always have to check which way is positive and negative. So now, if I want to find CD, I should be able to summate all the forces in the x direction. So I can just write that down here. Some of the forces in the x direction has to equal 0. And what do we have in the x direction? We have negative CD minus the x component here of KD cos 56.3 degrees. So minus KD cos 56.3. And what else do we have? We have KJ, and that's in the negative direction. So we already assumed that KJ was in tension, but the answer is actually in compression. So when we rewrite this, we need to make sure that we say that that is negative 66.7 kilonewtons. And a negative and a negative becomes a positive. So let's just write this one out. So I know what CD is. I found that that's actually what I need to solve for. And I know KD is 66. Where's KD? Here it is. It's 7.9 kilonewtons in tension, and CD is going to equal 74.6 kilonewtons, and it's actually in compression. So take a look at some problems on method of sections and see how you go.